Good morning, everyone. Welcome to our week 5 event of the KITP's Fundamentals of Gaseous Halos. We've now made it 50% of the way through the program. It's kind of mind-blowing to me. It's been a whirlwind so far. Hopefully you guys have gotten a lot out of it. I know I have, in terms of better understanding of the field, new ideas for collaboration, new ideas for projects. But we've still got 4 more weeks, so hopefully you've paced yourself. This week's focus is how does gas flow out of galaxies, both supernova driven and AGN driven. And you can see our layout of different themes for different weeks. So this week is outflows, next week is inflows, the week after that is the relationship between galaxy evolution and the gaseous halos, and then finally future observations that will transform our understanding of the CGM. So I'm pretty excited about this week, but I'm also excited about all the remaining weeks. So hopefully you guys share my enthusiasm. Just wanted to highlight my co-organizers, Jess Work, Mark Voigt, and Ben Oppenheimer. I think you guys have been doing an excellent job, and we've been making a lot of headway in this interesting topic. So thanks co-organizers. All right, yeah, just as a quick recap, in case you're lost or you're just joining the program because you only care about outflows and you don't care about any of the other aspects of the CGM, we have a Google document that you can go to with this bit.ly URL, and it provides basically all the base level information about what you've missed, as well as a detailed schedule and links to past lectures, recordings, transcripts, slides. Everything is there, so check it out. I use it as like my home base to make sure I know what the heck is going on. So it's updated constantly. A social event tonight. We will be having Astronomy on Tap on YouTube Live this evening. It's, in case you aren't familiar with the idea of Astronomy on Tap, it is traditionally it's hosted in a bar, so it's people drinking and talking about science. Obviously, we've moved online, so it's virtual. This will be streamed over the Caltech Astronomy YouTube channel. It starts tonight at 7:30 p.m. Pacific time, and there are 2 talks, as you can see, being given on the themes of this conference by participants in this conference. Jess Work will be talking about intergalactic immigrants, and Zach Hafen will be discussing exploring the virtual universe. So each of those talks will be about 15 minutes long, and then a couple of Q&A, a couple minutes of Q&A for each. And then at 8:30, we'll have astronomy-themed pub trivia that is interactive using the same menti.com interface that we use for Friday's structured discussion. And it's super fun. It's obviously these events occur once a month and are geared at the public, but we're kind of co-opting it this month to be more about the KITP themes. So feel free to join, or feel free to join just for the pub trivia or just the talks or whatever you're really interested in. But there's a link here, but it's also in the social, the Halo 21 social channel. Oops. Okay. Consistent with YouTube, we have continued to get more and more entries to our new results channel, which goes to the YouTube channel specific to this KITP program. So as a reminder, these are 4-minute summaries of new results, either papers that were submitted in 2020 or 2021, or some results that haven't yet been submitted. But it's a really good way of kind of like keeping up on what the relevant new science that's being done without having to go in detail through the archive every day. And yeah, so I encourage people to submit. There's a video on how to generate a video. So hopefully it takes people through all the difficult steps. So last week we had 8 submissions. some really interesting ones as well, some of them themed. So to the discussions that we've been having, there was a summary by Priyanka Singh on constraints of precipitation limited hot halos that was super interesting. There were a couple on Milky Way stuff. So Hannah Bish had this one on the Quastar survey, and then Matali Damle had this cool one on the connection between the Milky Way and M31's CGM from simulations. Related to that, there was a really cool one, again, on sharing a CGM between two structures, in this case, a dwarf and a massive galaxy by Hasti Nategi. And then there were 3 different ones on different aspects of metallicity and metal enrichment, including dust by Rajeshwari Dutta, Yucheng Guo, and Martin Wendt. Finally, there was a really interesting one that Crystal Martin and Zhu Yun assembled about this crazy system, this one galaxy that has both a thermal wind, a cosmic ray driven wind, a cold flow, and a dark satellite. So I encourage you guys to check those out. And yeah, they're each only 4 minutes, so you don't have to take up a ton of time to get the deets on what's going on in the field. We also, on that same page, highlight junior scientists who are on the job market, or who may be on the job market at some point in the near future. Pictured here is Paco Hogwin, who is a PhD candidate at Michigan working with Mateusz Ruszkowski. And yeah, this is a way that people can kind of get some exposure within the community in ways that we aren't really able to do this year because we're doing so much stuff online. So he's our only submission, so go check him out. And if you too are on the job market, I encourage you to make a 10 to 15 minute video. But you can go to the Halo 21-on the market Slack channel and submit a video there, or find out more about what to do. But it'll go to the same YouTube channel that our new results are going. It's just a different playlist. So thank you, Paco, for submitting your submission. Okay, so a couple of featured conversations this week. One, we're going to, not today, but on Friday, we're going to get an update. There's been a lot of activity in the metallicity channel since week 1, really. There's been ongoing work between Zach Hafen, Jane Charlton, Samir, myself, and a few others trying to create synthetic observations where we know all the details from simulations, and then see if the observers can reproduce what we've coded in there in very simple cases. So we'll hear an update of that on Friday, but it's a lot of cool ongoing work that's going on there. And we'll also hear today from the visualization group, our featured conversation in the visualization group, led by Joe Burchett and Stephanie Tonnesen, and I think Dylan Nelson as well. They're deeming this week Visualization Week. So there will be a bunch of really cool themes surrounding that, and I believe a challenge to everyone participating to potentially provide their biggest request on some aspect of things that they want visualized. Related to that, there's the Mark Voigt started the Halo 21 Beauty channel, which is beautiful images, either observed images or simulated images. That's super cool and really inspiring. So I encourage people to check that out, as well as submit their own examples of that, whether they produced it or they just saw it somewhere online or a collaborator. And then there's the Halo 21 AGN group, since that's obviously related. AGN are related to Outflows, the theme of this week. So I encourage people to check those out. And we'll hear again from them on Friday after today. So yeah, today's activities are, we'll hear from the Viz group, and then we'll do speed collaboration. We'll get back to this in a second. I'm just taking you through the activities of this week. Sorry, these announcements are a bit long this week. You know, Mondays we try and lay out everything for the week. So just to give you guys a heads up of what's going on. Tuesday, we will have a talk, keynote talk given by Dylan Nelson from Heidelberg on the theme of this week. How does gas flow out of galaxies? And then we'll follow it up with a panel discussion featuring Rongmon Bordeloy, John Chisholm, Ramil Dave, Chengu Kim, and Miao Li. So I'm pretty psyched about that. I think that's a really good group. We will have interesting tutorials on Wednesday. So Joe Burchett is going to, consistent with the visualization theme of this week, is going to give a really cool demo of a tool he's been creating over the last year called CosmoViz, and how you can use it to visualize interactively within your web browser. Super cool. The cosmic web and the CGM, and then send sightlines through it to probe individual things. It's really an awesome tool, and I think he's requesting beta testers to get feedback on the design. So that will be awesome. At 8:40 on Wednesday, we will have a talk by Evan Schneider on mass loading in galactic outflows. So these are all tutorials teaching you some skill that you may not be aware of or possess at that point. So I'm pretty psyched. Mass loading has kind of baffled me in the past, so I'll certainly be learning something from Evan's talk at 8:40. And then finally, we're going to hear about Voight profile, absorption line fitting, that sort of thing with Marie Lau. And I believe she'll also be joined by Joe Burchett as well as Rongmon Bordeloy for different tools for fitting absorption lines. Now, maybe you observers have it all figured out, or maybe you just have your one tool that you use for fitting these sorts of things, but us theorists don't really know what goes into this. So I think it'll be really beneficial for breaking down the barriers between these different communities. Also on Wednesday, there are a couple of after parties that people have announced. The Cosmic Ray Group, led by Chad Bustard and Christoph Fromer, will be hosting an after party at noon that day to discuss cosmic rays. Go to the Halo 21 Cosmic Rays channels to find out the link to that particular thing, but that should be pretty cool. And then right after that, at 1 o'clock on Wednesday, there will be a visualization discussion led by Joe Burchett, Stephanie Tonnesen, and Dylan Nelson. I'm sure we'll hear a bit more about that today when they speak in a couple of minutes. And then finally, Thursday, we will have our second keynote of the week being given by Tim Heckman from Johns Hopkins. And there will be a panel discussion featuring Cassie Lacus, Crystal Martin, Evan Schneider, and Chuck Steidel talking about outflows in galaxies. And then Friday, we'll hear from our featured conversations again, and we'll have structured discussion like we have in the last few Fridays, where you get to pick which questions we discuss, and then we break into small groups and talk about those relevant questions to the theme of this week. So again, a reminder for today, I will turn it over in just a moment to our visualization leaders, Joe Burchett and Stephanie Tonnesen, and perhaps Dylan Nelson as well. And then following their discussion, we will jump into speed collaboration, where we pair up with other people and kind of break the ice and get an idea of what topics we have in common, and meet more people from the community one-on-one in 5-minute little randomly selected breakout sessions. Okay, I will turn it over to Joe, Stephanie, and Dylan.
Thank you. Okay, so it is my pleasure and Stephanie's pleasure to introduce the Halo 21 visualization conversation group. So this there's already been quite a bit of action happening here on this in the corresponding Slack channel, which you see written here. And among that action is this image that's on my first slide here. This was posted by Dylan Nelson. Just an absolutely breathtaking view of shock structure in the circumgalactic medium and intergalactic medium. I think this is representing a volume about 300 megaparsecs across, 40 megaparsecs in the other direction, something like that. So we're really getting a sense of the large-scale structure in the TNG simulation that is kind of a really unique, scientifically useful and beautiful example. So I just wanted to lay out some goals for this group, and the idea here is to bring people together, both observers, simulators, even visualization experts who may not be astrophysicists, to share their tools, share their methods, inspire one another, identify how observers and theorists can communicate through visualization and through visualization methods to inspire each other and collaborate more fruitfully, and as well forge new collaborations, as I mentioned, between observers and simulators, but also with visualization personnel, which I'll talk more about in a sec. And just to bring some exposure to how powerful visualization can be for our science, for public outreach, and all sorts of things. So some events that will be going on. First and foremost, we have our Slack channel. As I said, some conversations already been happening there. People have been sharing their examples of visualizations and movies and so on. Please continue. We've already seen some great stuff. We are honored to have joining us my collaborator, Angus Forbes, who is a visualization expert. He runs the Creative Coding Lab in the Computational Media Department at UC Santa Cruz, and is just an excellent resource for all things visualization, machine learning, all kinds of stuff. Cameron mentioned our after party happening on Wednesday. This will be at 12:30 p.m. Pacific time. It's sure to be a hoot.
Is it at 12:30 or is it at 1?
It is.
I thought we just moving it back to 1.
We did. We move it back a half hour. Thank you. Sorry. Outdated slide here. So yes, 1 p.m. on Wednesday. That's Pacific time. And lastly, a plug for the CosmoViz tutorial happening Wednesday. It should be the first, I think it's scheduled to be the first tutorial on Wednesday's session. I am recruiting beta testers, alpha testers. I'm not sure the difference, but please join, and I think it should be quite a bit of fun. Okay, so I'll now turn it over to Stephanie. I think she has some inspiring examples to get things heated up for the remainder of the week, for the remainder of the workshop.
Great, thanks. Let me see here. I think I'll share first, and then maybe be able to. Okay, do you all see my slideshow or my presenter tool? Slideshow, excellent. Okay, so we've had it really easy, I think, because everybody this whole meeting has been using amazing visualizations, and that's basically the bread and butter of astronomy and sharing our work. And so I just wanted to touch on a couple images. It was incredibly hard for me to choose, and some really good visualizations that I liked just from the plenary talks. I mean, there's been so many amazing viz things. I was watching them over breakfast this morning, and I was like, oh, I wish I should put that in. I should put this in. But we don't actually have 2 hours to look at a greatest hits reel of viz. So anyway, so I thought that I would just show a couple visualizations and actually really highlight that I don't think that we're really talking about visualizations always in terms of 3D movies like I'm showing here, right? Viz is a really broad topic, and we really want to try to bring everybody into kind of discussing what's really useful for them. So from week one, we have this image of a density temperature diagram, which happens to be my go-to diagram, as Joe might discuss later. I love density temperature diagrams. And those might be fighting words, because I know there might be a few people on this call that like pressure entropy diagrams. And so we could have a discussion about that. But for me, it's rho-t all the way. And this is a great visual because we see this density and temperature, and then we also see the lines that we can actually observe at each of these densities and temperatures. And so this one, I think, is incredibly useful and really gives us a lot of insight into what observations are telling us about kind of the fundamentals of the gas. Another great visual is just these gas density profiles, right? We're looking at radial profiles of clusters. This is so nice and clean because you can put on analytic models and do a direct numerical comparison between your observations, numerical analytic models, simulations. So, you know, this is an incredibly powerful visual from week one. Oh, sorry, my week one got cut off. Okay, so moving on to week two, I thought this was really amazing from week two, just seeing how changing our spectral resolution changed the kind of number of components that we were seeing along a line of sight. So I thought that was a really powerful visualization. Then another visualization from week two is kind of this beautiful illustration that clearly shows the impact of T cool versus T free fall on precipitation. And so I don't need to even really see the numbers, just, you know, this gives us an intuitive interpretation of what's going on here. Then on a similar note, from week three, we have this mixing layer slice, which I really like because, you know, first, that top slide is really beautiful. I really like that we have drawn on there the variables for really kind of understanding what's going on in determining the mixing rate. And then, unlike the previous slide where we kind of got a really visceral interpretation of how different those different T cool over T free fall is, just by looking at these images, we can really see how radiative mixing layers are related to these turbulent combustion layers. And so, you know, this is a really beautiful visualization. Another one from week three is, you know, these observations of magnetic fields and synchrotron filaments in galaxies. And so, you know, I think that for simulators to try and reproduce this kind of observation is going to be really key for trying to constrain, you know, non-HD physics in simulations. And so these kind of images, I think, are really awesome. Then this one, I took a little bit of privilege and grabbed the actual image from the paper rather than this slideshow slide to show kind of this work where you're comparing simulations in every single one of these panels, except for the bottom right corner, which is an observation. So this is all done using exactly the same code so that you can get a really nice visual interpretation of which of these simulations is well matching the observation. And then another one here, I feel like we could have an entire VisWeek conversation on this image, honestly. You've got emission, you've got absorption, you have gas at different temperatures, moving at different velocities, and then somehow we have to interpret, you know, we have these nice beautiful clouds here of H1, but you have kind of lines of sight for O6, and how correlated is everything and how connected is everything, and can we use visualizations from simulations to kind of understand the physics here, and what level of agreement do we really need to get kind of a good interpretation here between different visualizations. But, you know, on that same note, actually, oh, no, I'm not moving forward. There we go. Okay. we also saw some really excellent ways that simulations are agreeing with observations. And so in the color bars here are showing the simulations, the emission that you would get from ionized gas, and then they're matching with the points, which are the observations. And so you can get some idea there of the agreement between a simulation and observations. And something I'm really interested in discussing maybe is, is this good enough? Is this kind of the level of agreement we need in a visualization, or do we have to go further and try to really, kind of pinpoint exact agreements and disagreements? And then kind of on that same note, a discussion that I think is worth having is, what's the use of visualizations? Are they more qualitative or are they more quantitative? And, some I think are very clearly like, well, I don't want to say very clearly because I feel like I might step on some toes there. But, I feel like you get a really qualitative interpretation of what's going on. Some of them are more quantitative, where you can really kind of measure, you could determine how well fit different lines are. But in fact, most of the visualizations that I showed you, I think live kind of in the middle of this range, where they're a little bit qualitative, they're a little bit quantitative, and I think that might be the sweet spot of visualizations. And so I'm really interested to hear, how quantitative do we have to go? How much can we get out of a purely qualitative visualization in our discussions this week? But those aren't actually our challenges. And for that, I think I can go back to Joe.
Yeah, thanks. So having been inspired by all this beautiful work that we've seen already, we do want to pose a couple of challenges here. So first, this is to observers. And the charge is to name an informative image, plot, representation that you would like simulators to be able to make. So this is going back to the point Stephanie was just making, qualitative versus quantitative, and in terms of analysis, in terms of the ability to glean scientific insight. So this is one. The other is for anyone. And so this is to, some of you have been doing this already. Please show us your go-to visualization that's really informative and that you think everyone else should be making. So perhaps we can continue this pressure entropy versus rho-t discussion in our Slack channel and keep that debate raging. So thanks everyone. Let's have a fun week here. And looking forward to interacting. I see people are already hitting Angus up for recommendations over in the Slack channel. So let's keep all that going. Thank you.
Excellent. Thank you, Joe. Thank you, Stephanie. Yeah, I like this challenge, getting some more crosstalk between the different communities on what observers really want to see simulators actually produce from our simulations. So have at it, people. I think that's great. All right, so we don't have a second featured conversation to present right now. We'll hear more from the Metallicity group on Friday, but I want to move straight to our speed collaboration.